Implicit differentiation is used when it's difficult or impossible to get the equation into the y equals f of x form. Now, some of the methods I've been showing you earlier, showing you the way that we take the derivative, I was actually kind of employing implicit differentiation anyway, because what we're really doing here is we're going to take the derivative of both sides of the equation with respect to, now you always have to know what you're doing the derivative with respect to. Since we want dy dx, we're going to take the derivative of both sides of the equation with respect to x. Okay, so the derivative of x squared with respect to x. Well, that's going to be 2 times x to the first times the derivative of the guts. Now, what's the guts here? The guts of this one is x. So we have derivative of the x with respect to x, which, by the way, that reduces to 1, doesn't it? Okay, minus, now we have a product of variables, x times y. Now I just went ahead and wrote the minus. I think it's a good idea to go ahead and distribute the minus afterwards and just deal with the product rule inside the parentheses. So, product rule. First times the derivative of the second with respect to x. So the derivative of y with respect to x plus the second y times the derivative of the first x with respect to x. So dx dx, which by the way is going to be 1, equals, okay, over here on the other side, the derivative of a constant is 0. So you can write the 0, you don't have to write the 0. Maybe I'll go ahead and write the 0 just because. And then we have derivative of y cubed. So we have the power rule going on first. So I have 3 times y squared times the derivative of the guts. Now the guts is whatever's on the inside of that power. So the derivative of the guts with respect to x, so times the derivative of y with respect to x. Okay, now we are trying to find dy dx, so it's good that we got at least one dy dx in there somewhere. Okay, let's clean it up. Now dx over dx is 1, so I have 2x minus x dy dx minus y equals 3y squared dy dx. Okay, now we need to get the dy dx's together, and I would say let's move them to the right hand side. So we have 2x minus y equals, and I would have 3y squared dy dx plus x dy dx. Now, probably most of you are noticing there's going to be a GCF of dy dx. Well, sure. So we do need to go ahead and take advantage of that. So I'm going to move this up over here. It's important to always make sure that people can follow the direction of your work. So I have 2x minus y equals GCF of dy dx times 3y squared plus x, and of course then dy dx is 2x minus y over 3y squared plus x. Okay, so that's the first time we've ever done that. And by the way, when we do implicit differentiation, usually it will have a mixture of the variables involved. Rather than when we have it in the y equals f of x form, typically there's just x's there or whatever the variable is. Okay, let's go ahead and try number 2. Find dy dx. Okay, now some of you might be saying, well, gosh, let's just take the square root of both sides and then I'll get y equals. Be careful. Let's remind ourselves real quickly that if I have x squared, what is the square root of x squared? And be careful because it's the absolute value of x. And so if we were to square root both sides, the left-hand side, we'd have absolute value of y, and dealing with derivatives with all that, we just really don't want to have to deal with that. So we're going to do this one implicitly then. Okay, so I'm going to take the derivative of both sides with respect to x. So the left-hand side, I have 2 times y to the first times, now by the way, this is part of the reason why I don't like y primes. It looks like a y prime there right now. So I'm just going to put y because I don't want it to look like a y prime. Times the derivative of the guts. Okay, the guts is the y. So the derivative of the guts with respect to x is dy dx equals. Okay, right-hand side, quotient of variables. So we got to do quotient rule. Low d high minus high d low over low low. So low d high, which is 2x, although I'm going to put the 2x in front here, minus low d high minus high d low. The d low is 2x. I'm going to put that out in front. All over low low. Okay, now I'm trying to solve for dy dx, so I get dy dx equals 1 over 2y times, okay, let's clean this stuff up right here. Now there is a GCF of 2x, and I'm left with x squared plus 1 minus x squared minus 1 all over x squared plus 1 quantity squared. And if we clean up the inside, we get x squared plus 1 minus x squared plus 1. So the x squared is going, we're just left with a 2 right there. So the inside is 2 times 2x. So we have 4x over 2y times x squared plus 1 quantity squared. Okay, and now 4 times x over 2 times y times x squared plus 1 quantity squared. The 2 goes into itself once and the 2 goes into 4 twice. So final answer, dy dx 2x over y times x squared plus 1 quantity squared. Okay, problem number 3. Sorry, here's problem number 3. Let's see. 1 over root y. Well, sometimes it is helpful to go ahead and change things, the form of them. So 1 over root y. Isn't that really just y to the negative 1/2? And 1 over x, isn't that really x to the negative 1? Okay, so I'm ready to do the derivative of both sides. I want dy dx, so I'm going to do the derivative with respect to x for both sides. So I get negative 1/2 times y to the, what's 1 less than negative 1/2? Negative 3/2 times the derivative of the guts. What's the guts here? The guts here is the y. So dy dx. Okay, plus the derivative of x to the negative 1. Okay, so we've got negative 1 times x to the, what's 1 less than negative 1? Negative 2 times the derivative of the guts. Okay, what's the guts here? The guts here is just x to the first. And what's the derivative of x with respect to x? It's just 1. equals derivative of 2, derivative of constant, 0. Okay, now trying to get dy dx by itself. Now, as a general rule, if the original problem doesn't come with an exponential form, you should probably finish it not in exponential form. Let's see. We've got -1 over 2y to the 3/2. Okay, well, you pretty much need to go exponential form there. We're not going to do radical form, probably. I mean, we could. Dy dx equals, I'm going to move the x stuff to the other side so it becomes positive, 1 over x squared. Okay, and so dy dx is 1 over x squared times 2y to the 3/2 over -1. So positive times negative, we know it's negative. Dy dx is negative 2y to the 3/2 over x squared. By the way, don't leave a negative in the denominator. That's bad math grammar. Move it up to the numerator or just out in front. Okay, exponential form, you could write y to the 3/2 as the square root of y cubed as well, but probably just exponential form there. But no negative exponents usually. Okay, number 4, find the second derivative of y with respect to x. Well, how do we find the second derivative of y? First, you have to find the first derivative of y. And so we're going to do the derivative of both sides of this equation by dy dx, so with respect to x. Okay, so the derivative of x squared with respect to x, I have 2 times x to the first times the derivative of the guts with respect to itself, dx dx. Okay, plus I have 2 times y to the first times the derivative of the guts with respect to x, so dy dx equals 0, because the derivative of a constant is 0. Okay, so I'm trying to get dy dx by itself. And so dy dx is negative 2x over 2y, which is negative or opposite of xy. So there's the first derivative of y with respect to x. Now, if I'm going to get the second derivative of y with respect to x, we are going to take the derivative of this equation with respect to x. So, and I'm going to move it up over here. Okay, so we get the second derivative of y with respect to x right here equals, okay, now, negative. Let's just say the negative goes with the numerator right there. It's quotient, so quotient rule, low, d high, with respect to x. You have to know what you're doing the derivative with respect to x to. So, negative dx dx, low d high minus high, remember that the negative is going with the numerator, d low with respect to x, all over low low, so low low squared. Okay, so we've got now negative dx over dx, that's just 1, so negative y minus a negative, so plus x times dy dx all over y squared. Okay, well, we can't leave it like this. If only we knew what dy dx is. Oh, we do know what that is because dy dx is right here. And so if we substitute opposite of x over y for the dy dx, we can continue to simplify this. So I've got negative y plus x times opposite of x over y squared. Okay, so that's really opposite of y minus x squared over y all over y squared. Okay, you never get to leave a complex fraction as a final answer and get full credit. We need to multiply top and bottom here by y. And so if I do that, we get negative y squared minus x squared all over y cubed. Okay, well, there's a GCF of -1 up top, so let's factor that out. So let's hold that out in front. So y squared plus x squared all over y cubed. And you're going, okay, good, that's good. And yet, the final answer, if you'd be checking it in the back somewhere, would be opposite of 25 over y cubed. How does that happen? Well, let's take a quick look here. Y squared plus x squared. Didn't we see that in the original problem? That's right. X squared plus y squared in this problem is equal to 25. And so I substituted for the y squared plus x squared, I replaced it with the 25. And so there's the second derivative of y with respect to x. Okay, one last problem here. Find the equation of the tangent line and the equation of the normal line to x squared plus xy minus y squared equals 1 at the point 2, 3. Okay, well, if I want the equation of the tangent line, I need dy dx. So let's get dy dx. So I'm going to take the derivative of both sides with respect to x. So I get 2x times the derivative of the guts with respect to x plus product of variables, x times y. So the first times the second times the derivative of the second with respect to x plus the second times the derivative of the first with respect to x minus 2y times the derivative of the guts with respect to x equals 0 because the derivative of a constant is 0. Okay, we want dy dx, and let's overall clean this up. So I've got 2x plus x dy dx plus y minus 2y dy dx equals 0. I have two dy dx's. I'm just going to leave them here. And there's a GCF of dy dx then. So dy dx times x minus 2y. Now, the 2x plus y, I'm going to move them to the other side. They become negative 2x minus y. And we get dy dx equals negative 2x minus y all over x minus 2y. Okay, now we are going to be evaluating this at the point 2, 3, but before we do that, if all I was asking for was dy dx, this would not be the answer. This is not a full credit answer because it's not simplified as much as it can be simplified. we try to have the fewest number of negatives possible in a final answer. So since it's a fraction, I could multiply top and bottom by -1. Sorry, I want a different color here. So if I multiply top and bottom by -1, I'm not changing the value of the original problem, but I am changing what it looks like. And so I get 2x plus y all over -x plus 2y, or 2y minus x. So here's dy dx, and I want to evaluate dy dx at the point 2, was it 2, 3? Yeah, 2, 3. Okay, so 2, 3. So I have 2 times 2 plus 3 over 2 times 3 minus 2, which is 4 plus 3, 7, over 6 minus 2, 4. Okay, that's the tangent slope at 2, 3. Now, what is it we know about the slope of the normal line? Perpendicular, right? Therefore, the normal slope at 2, 3 is perpendicular slope. So, -4/7. Okay, so now, if you're willing to write the equations in that nice form for lines, you'll be done in about 20 seconds. Y minus 3 equals 7/4 times x minus 2. There's your tangent line. And your normal line is going to be y minus 3 equals -4/7 times x minus 2. There's your normal line.